Hello guys, welcome to the live session of Excelencia. In today's session, we are going to start preparing for our NEET 2021, which is on 12th September. Here I have written that 20-day strategy for 130 plus score, but obviously we are preparing for this particular exam for a very long period of time. We have prepared chapters from grade 11th and 12th. But what we need to understand that during this 20 days, we should be at the peak of our performance, because there are a lot of concepts which you people have to revise and go through again. So what I'm going to tell you, like how you can actually cut down on the portion, because here in this session I'm going to cover a very important topic which I feel like, and at the same time I'm going to give you some ideas and I'm going to give you some skill by which you can actually solve more numericals. Correct? Okay. Now, in case if anyone who is not familiar with the exam pattern, let me tell you, this 2021 exam which is going to be happen, here we have 4 subjects: physics, chemistry, and botany and zoology. Earlier we used to say physics, chemistry and biology, but this year you can say that biology has been divided into 2 parts. So botany and zoology will also have a different subject. We can treat them as a different subject. Looking at the paper pattern, you need to understand that all 4 subjects have the same paper pattern. So I'm going to explain you about the physics, where you can see it has been divided into 2 parts, section A and section B. Similarly, chemistry, zoology and botany, you can say that. If you look at the section A, we have 35 number of questions which you have to attempt all. In section B, we have 15 questions. So if you do the total, you will find there are somewhere around 50 questions in physics. But as we know that, there are always 45 questions when it comes to physics. What you need to understand that this 15 question which you have a choice. You can leave 5 questions and you have to attempt only 10 questions over here. So ultimately, the total number of questions will be 45. Okay. Accordingly, the similar pattern will be followed by the chemistry, botany and zoology. There is one particular skill which you people have to develop over here, because till now we used to get 180 questions in our paper. But this year you can see the number of questions are going to be 200. So there are 20 more questions which you people have to read. Because definitely why I am saying that you have to go through all the 200 questions, because you people have to identify that which question you can attempt, which is easy, which particular chapter you have learned. Okay. So apart from concept, you people also have to develop a very key skill which the examiner is going to look forward is your reading skill. Okay. So your reading speed should be good enough so that you should be able to at least go through the entire question paper. So you have to read 200 questions, where definitely people actually attempt bio first, which is having a 50% of the weightage of the entire portion, and then you go for physics and chemistry. Now I'm going to specifically deal with physics over here, and I'm going to tell you that how you can easily score 130 plus score at the last moment. Definitely our aim is to get more than 160, 165, but if anyone who is a bit panicked and he is not sure about this particular subject, because mostly people from medicine field, they avoid numericals in physics, yeah. So they keep physics as their last option, yeah. But definitely it's a key subject. One can actually increase your ranking overall. Now when I talk about the important topic, my aim is to actually, in today's session, I'm going to deal with mechanics, because mechanics is one particular topic which you have learned in grade 11th, yeah. And when we talk about mechanics, we have kinematics, Newton laws of motion, work energy power, circular motion and simple harmonic motion. Definitely there are a few more chapters, but I have jotted down only the chapter which I feel like which are very important according to our this year paper. Because ultimately you people have seen 2020 year paper was a bit different, the difficulty level was moderate, it was not that difficult, so people have to plan accordingly. So during this 20 days, make sure that you should not leave any specific chapter which I have written under mechanics. Okay. Now the second unit which I have written, which I am going to do in my next session, it is electrostatic, in which you have the first two chapters of your grade 12th, electric charge and electric field, and then electric potential and capacitance. The third session will consist of current electricity, okay? This is one particular unit, and you also have a same name of the chapter, which is current electricity. My session 4 will consist of optics, in which you people have two chapters, ray optics and wave optics, and my last session will consist of modern physics, which also play a very crucial role in our NEET exam. So dual nature of matter and radiation, atom and nuclei, these are the three chapters which will come under modern physics, in case if you're not aware of. Now look here. These are the topic which I've written. Definitely you have to revise during these 20 days. I will definitely not recommend to add any new chapter during these 20 days, because definitely you people have already studied so many chapters. So you should not leave any chapter which I have written in this particular unit, okay? Because we are trying to get a good decent score in physics. So this particular unit, all this unit which I have written, they are very important, okay? Now there is one more thing which you need to understand, that what will be our learning objective when we are going to deal with mechanics over here, okay? Because mechanics is definitely, it's huge in terms of portion. There are a lot of questions comes under mechanics, and definitely it takes time to build confidence when it comes to mechanics. So that's the reason I have taken this session today, because you people have learned mechanics last year. So we'll brush up few numericals from mechanics in this session, and definitely electrostatic, current electricity, optics and modern physics. These 4 units are from grade 12th, which definitely bring a smile on your face, because you people have learned this topic this year, correct? Okay. Now the learning objective of today's session is what? Like how to solve numericals. So when you have mechanics, definitely there are a lot of numericals. So your numerical solving ability is a very key skill over here, which you need to understand, because let me tell you, out of 50 you can expect 30 to 35 numericals, okay? This year paper, 30 to 35 numericals. So that means there is no way we can avoid solving numericals, okay? Now when I'm going to solve the question, I want you people to think according to me. So there are few things which always comes in mind whenever I approach any specific numerical. The first thing, whenever I read a question, okay, I make sure if the diagram is given, good. If diagram is not given, I'm going to draw a rough sketch of that particular question, so that I should have all the information from that question at a single glance, okay. Second thing, I'm going to definitely relate which concept is applicable over here, okay. The moment I identify the concept is basically, you can also identify the chapter name of that particular question, because we are dealing with somewhere around 25-30 chapters. So the moment you identify the concept, definitely there is a list of formula which is going to be flashed right in front of you, okay, because there are so many formulas. What you need to do, you have to select a formula, okay, according to the requirement which is there in the question. So the moment you read the question, you're able to identify that what exactly is the requirement of that question. So we have to attack the requirement of the question. But let me tell you, after doing all these 4 steps, the very crucial part is actually there are 4 options given to you. So you have to keep on solving till the time you can actually reach the correct answer. And then finally we can take the correct answer. So whenever I am going to approach any numerical, you people need to understand these are the few steps which I am going to follow. So when we are going to solve the numerical, I want you people to follow the same technique, okay. Now let's go to the today's topic which we have taken as mechanics. So we are going to solve multiple previous year questions from mechanics, and let's see how to approach those particular questions, yeah, okay. Now let's do it. Now when I see the very first question, okay, it says a balloon is rising vertically up with a speed of 40 meters per second. A man drops an object at an instant when balloon is 100 meters above the earth's surface. There is no diagram. I will quickly draw a diagram for you. So you can consider there is a hot gas air balloon. There is someone over here, and this man is drop an object, and at that particular point the height from the ground has been given as 100 meter. Okay, makes sense. The question says calculate the time taken by the object to reach the surface of the earth. Okay, I know that this particular question is from definitely I told you I'm going to revise mechanics, but in mechanics if you have to specify the chapter, it is motion in 1D. Okay, so this is a part of a kinematics. We know that in this case, even if it is not given, we know that gravity is something which is going to be act down, and the value of gravity is 10 meter per second square, which everyone knows. One more valuable information which is given is the speed of the balloon, which you can draw an arrow over here, and you can say it is 40 meter per second, correct, which is given to you. The object has been dropped. Now usually what happens when we read this particular word that object has been dropped, we consider that the initial speed will be 0. Okay, but look here, what we have to figure it out. We have drawn the diagram, we have identified that this particular concept is from motion in 1D, and the formula is definitely one of the equation of motion we have to use, and I'm writing that equation of motion which we can use over here is S equal to ut plus half at square, which is the second equation of motion which we have. Now it's very important, the key concept, the requirement. The one particular mistake which you can make is in the sign convention, because when you plug the value, you have to ensure that you are plugging with the correct sign. Now let me tell you, when we talk about displacement, now we should be very clear with the definition of displacement. It is the shortest distance between the 2 points. If you look at the object, you can't say that object is going to go simply down from this 100 meter and it will hit the surface. Why? Because the moment you drop something from a moving frame, here your balloon is a moving frame. It is moving up with a speed of 40 meter per second. So definitely whenever you throw something from a moving frame, that object also have the same velocity as your moving frame. So the question says drop a stone. You can't say it is having an initial speed which is 0. It is having an initial speed which is going to be imposed on the object by the balloon. Just like you are sitting in a plane, but jumping out of the plane doesn't mean that you are not going to get hurt because your speed is 0. You definitely possess the same speed which is the plane is having. So this is what one thing which you have to notice, that the object which has been dropped from a moving frame, it will also have the same velocity, and definitely in that case it look like that okay, that means this object is going to travel up and then it is going to go down in this way. Now when we talk about displacement, for displacement you talk about the shortest distance between the 2 points. One thing which you need to understand, that here basically if you are saying that some distance has been traveled up by the object, let's say it is I am writing some d, the same distance traveled by the object when it come back to the same initial position. If traveling up distance is taken as plus sign, traveling down will be taken as minus sign. So what will happen, you don't have to bother about what distance is actually traveled by the object when it has been dropped, because that is going to be get cancelled. Ultimately the only distance, or to be very precise, the only displacement which is traveled by the object is the one which is nothing but the height from where the object has been dropped. To be very sure, let me tell you, the object is traveled distance down, and according to sign convention, anything which is down, it should be taken with a negative sign. So when I am going to plug the value of displacement, it should be plugged as minus 100. Okay? If you make a mistake in a sign, definitely you will get a wrong answer. So you have to be very precise when you're plugging the value. Speed, initial speed, and definitely I can see the object is having initial speed 40 meter per second, which is up. So I can say it is 40 meter per second, and your time which we need to calculate, it is t, because that is what basically the requirement of this question is. I'll keep it as t. Then I have my constant, which is half, acceleration due to gravity, which is down, which will bring a minus sign over here. My acceleration due to gravity is 10, and t will remain as it is, t square. Now we are done. After that, let me tell you, the physics part is over. It's only the mathematical part which we have to deal with. So I will say 100, this is 40t, and this is minus 5t square. Let's modify our equation. So when I take 5t square and 40t to the other side, they will have opposite sign, minus 100, and this is 0. This looks like a quadratic equation to me, which is very easy to solve. I can divide the whole equation by 5. I will get t square minus 8t minus 20 equal to 0. And if I solve this, t square minus 10t plus 2t minus 20 equal to 0, take t common, it will be t minus 10 plus 2 t minus 10. You have two factors which you can say t minus 10 and t plus 2. Definitely there should be no confusion when we have to figure out the correct answer, because one of the time value, when you say t minus 10 equal to 0, it is t equal to 10, and the other time value is minus 2. And everyone knows that time cannot be negative, so that means the correct answer for this question is going to be 10 seconds. Okay, so this is the way we have to solve the one particular question. Yeah, I told you that I'm going to teach you that how to approach any numerical. Okay, and these are the thought process which you have to involve. Definitely the key skill is that how fast you able to solve this particular question, so you can definitely reduce the time, and which can happen only when you practice a lot of question in physics. Correct? Okay. So the same technique we are going to apply for the next question as well. So we will see the next question now. I hope everyone is clear with this particular question. So let's move on to the next question. Here we have. Okay. In the given diagram, calculate the reaction force exerted on the 5 kg body from the ground. Now the diagram is given to me. You people have to understand, first thing, okay, diagram, it's there. Second, which concept is applicable over here? When it comes to concept, definitely it is actually part of Newton's laws of motion, where we calculate the action-reaction, the Newton's third law. We have to calculate the reaction. So that is what the concept which is involved over there. But the requirement is we want a reaction force on 5 kg body. Definitely now we have to go according to the requirement. So we have to attack that particular requirement of this question, and that can be approached only when you are good with your free body diagram. Very important concept we have in Newton's laws of motion when we talk about free body diagram, which is usually we call it as FBD. In case of FBD, what I will do, I will simply isolate my body and I will draw the component of forces separately. As we know that the mass is given, so the weight of the body will be mg. So what you can say, 3 into 10 will give you 30 Newton, because weight is something which is always down, so there is nothing which you have to worry about. And definitely because of the body has been placed on 4 kg weight, there is going to be some reaction on the body, which I am drawing on the 3 kg body over here, and I am writing that this is what the reaction on this body, which can be written as N. Now if you look, we know that if we have the free body diagram, I can simply say that my normal minus 30 Newton, because I am using my formula F is equal to ma, where net force equation I am using, so N minus 30 should be equal to ma. The net force can be calculated by N minus 30, but acceleration is definitely 0. So definitely if you people are familiar with the situation, you can directly write that your normal is going to be 30. The upward component should be equal to the downward. So N can directly be written as 30 Newton. But the point here is the aim is not to calculate the reaction force for 3 kg, it is for 4 kg. So let's move on to the next diagram. It is 4 kg. I can say that the weight of the body, 40 Newton is down. Definitely some reaction is going to be experienced from the 5 kg body, which I am writing it as N1 now. Okay. There is one particular thing, if you are thinking that your diagram is complete, please ensure that this is the reaction which you have drawn on 3 kg, which is going to be exerted by 4 kg body. If this is the reaction, the action is going to be happen on the 4 kg body. Action reaction pair. So this here should be your N. So what we need to understand that here the upward component look like to me is N1 and there are two downward component, as you can see 40 Newton plus this N, both are downward, so I have to simply say my upward should be equal to downward. So add 40 and N. You people have already calculated N, which is 30. So 40 plus 30 is going to give you 70 Newton. Correct? I hope you people are clear that what we are going to approach, that we are very close to get the final answer. So the aim is to get the reaction forces on 5 kg. First component, the weight, which is 50 Newton down. The reaction from the ground, this is what the examiner want. So this is my answer which I need to calculate, N2. But let me tell you, as you people have figured out that you have drawn the reaction N1 on 4 kg body, this reaction is also going to be happen on 5 kg body. So when we actually going to solve this particular question, upward, which is N2, you have two component which are against or opposite to that N2, which will be N1 plus 50. You already have the value of N1 which you have taken at 70. So your N2 value is going to be 120 Newton. It's very important that you people should know how to calculate the reaction force, because there are a lot of questions in Newton laws of motion where you have to calculate this N. So this calculating this normal reaction is a fundamental need if you have to calculate anything with respect to the force of friction, which is usually written as force of friction is equal to mu N. So you need this value over there. Okay. So normal is something which should be very basic and you should be able to calculate it. There can be a difficult situation where the normal is you have to identify in this particular way, but you need to understand the correct way. So basically the concept over involved here is Newton's third law, action reaction, and you should be able to correctly identify the action and reaction pair. So that is what the answer is. So for this question we can say that reaction force on 5 kg body is going to be 120 Newton. Yeah, I hope everyone is clear with this particular part over here. Now let's move on to the next question and let's see that what exactly the next question says. Okay. Now when I read the next question, it says in the given diagram, calculate the tension acting on 1 kg, 2 kg body, and angular velocity is given to me. Okay. Angular velocity, where you can say the symbol for angular velocity is omega. So I will do one thing. I will mention it over here that my omega value is given to me, which is 2 radian per second. Now look here. Again, the concept which is involved, the diagram is given, we don't have to do anything about it, but the concept which is involved over here is definitely Newton laws of motion, and we have to do this question also. The requirement is we have to calculate the tension. If we have to calculate the tension, definitely we have to again take help of free body diagram. Okay, and there is one important thing which I am going to tell you, that you can always approach this particular question with the help of the free body diagram, but you can draw the diagram in such a way that you can consider yourself on the body. So when I actually draw the tension, there is a beautiful concept of tension which you can read over here. When I say this is the tension which is going to be experienced in the wire, similarly there will be some tension over here. We'll calculate both T and T1. There are two different strings, so tension will be different, T and T1. You need to understand that this T which I have drawn, this tension direction belongs to 1 kg, because according to the definition of tension what we have, the tension can only be a pulling force. Connecting a string with a chair, you can only pull the chair, you cannot push the chair. So if you draw this direction of T between 2 kg and 1 kg, definitely this tension is look like a pulling force on 1 kg body. If you have to deal with the same tension, that how this tension will appear to be on 2 kg body, this direction is not going to be valid because it appears to be pushing the 2 kg body. For that, what you have to do? You draw your tension in this way. Definitely the direction is different for 1 kg and 2 kg, but both the value of T will come same. But that doesn't mean they are going to cancel out each other. It is just the approach which we need to require over here. So what we can do, now we are going to deal with this particular situation. I am going to isolate, because this looks very complicated to me. What I am going to do, I am going to isolate this 1 kg body. And let me tell you, when I isolate this 1 kg body, what I can see that there is a tension in this direction. Okay, is there any other thing which is involved over here? Definitely any body which is performing a circular motion, okay, there is always a centripetal force which is there. So the person who is actually standing on this particular object of 1 kg, he is going to experience a force which is taking him away from the center, which we call centrifugal force, which is also known as centrifugal force. Now this pseudo force, that means this force, which we write MA, but as it is a centripetal, we need to know it is acceleration is taken as mv square by r. One thing which you people need to understand, that we have to deal with angular velocity, and we know the relation between angular velocity and linear velocity. So what you can do, this force you can write in terms of omega, and it will appear to be mr omega square, because the moment you will plug the value of v, which is r omega, you will find r square omega square, there is r, you can cancel this. So mr omega square. So any body which is moving on a circular motion, there is some kind of a pseudo force exists, and that pseudo force you people have to draw. So ensure that you write this mr omega square over here, because now all the component of forces are shown on the body. What we need to understand, that if you have to make an equation according to the Newton's second law of motion, the net forces on this body can be written as the tension is going to be equal to mr omega square. Our aim is to calculate the tension on 1 kg body. I can simply say the tension, it is 1 kg, so mass value 1, radius, okay, this body has been located at a 2 meter distance, so be careful, and omega is given to you as 2 and square of it. That means tension in this case is going to be 8 Newton. Wonderful. We get the first part of this question, that tension which is going to be experienced by 1 kg body will be 8 Newton. Now we need to figure out that how we can calculate the tension which is going to be experienced by 2 kg body also. Now let me tell you guys, when you isolate 2 kg body, look at this particular part, because always is it better to draw a free body diagram, otherwise you will get confused with the diagram which is given to you. So when I isolate this 2 kg body, I can visualize that my tension 1 is here. I can also say that my T value, the tension which I have to show, this is what the direction which I have to take when it comes to 2 kg body, because that is what it appears to be a pulling force on my 2 kg body. Okay, so it's very important to identify the correct direction of tension, otherwise your entire calculation will go wrong. There is one more thing which you have to understand, that this body is experiencing mr omega square, because 2 kg is also performing a circular motion. Any body which is performing a circular motion, you have to involve the concept of pseudo force, so that mr omega square is going to define that particular force which is going to be experienced by that body. Now what we can do, guys, if you wanted to show this component with the body as well, you can show it. Now we need to understand, when we write an equation here, when we are calculating the value of T1, it is equal to T plus mr omega square. So you have to be very careful when you draw the diagram, make sure that you write the value of T, otherwise you are not going to get the correct answer. So when you have made the equation, T value you people have already calculated 8 Newton. The mass is 1 kg. For second body, ensure the distance from the fixed point is given as 1 and omega is 2. Now if we solve this particular part, T1, I have 8 Newton plus, this is 4, my T1 value is going to be appear 12 Newton in this case, and that will be my final answer. Okay. So guys, we need to understand that how the free body diagram playing a very crucial role whenever it comes to mechanics. Most of the question in mechanics can be dealt easily when you know the correct way to draw the free body diagram. Okay. Now let's go for the next question. We will see here the question number 4. Now again, when you read the question, remember diagram is there. Concept we need to identify when we read the question. The third thing, we need to identify the formula. There are a list of formula, and then we will solve. Now when I read this question, it says a small mass m is attached to a massless string of length L. Okay, so the length of the string is given to me, whose other end is fixed at point P as shown in figure. The mass is going in a circular motion in the xy plane with center O with a constant angular speed. Calculate the angular velocity for stable circular motion. Okay, the values are not given to us, so definitely we will get some answer in terms of variable quantity, not a problem. Now what you can do, this mass, when we approach this question, wherever the mass is, you draw the lines which represent x-axis and y-axis at that particular mass. So the red line I have drawn, it represents my y-axis. Definitely there will be some kind of a tension in the string, which I can write it as T. Question says calculate the angular velocity. That means I have to calculate omega for stable circular motion. The word stable is very important because you need to know that when you say stable, that means with respect to that mass m, the upward forces and downward forces should be same. The forces which are acting on left side, right side, they should always be same. So what we can do, when I resolve this T, I am going to get the component of this. If this theta is given to me, I will say this is also the theta which is known with the body. The component which is adjacent is always written with cos, and the component which is opposite, it is always written with a sine. So I have resolved my t cos theta, t sin theta. One component which you can draw blindly is the weight of that particular object, which can be always drawn downward. Now you people need to understand one thing. What is that? When it is a case of circular motion, you have to involve your pseudo force. In this case, when you're talking about the body which is moving in a circular motion, you can see the center which we are talking about. The body is performing a circular motion with the radius small r. So according to this circular motion, the component which is going to be act away from the center, we can write here as m r omega square. We have to calculate this angular velocity. So we will calculate this angular velocity. So that's the reason instead of writing mv square by r, I am directly writing mr omega square. Because for centrifugal force, you can write mv square by r, you can also write mr omega square. Now let's try to approach this particular question, that how we can get the answer. First thing which I will do, I will take my x-axis, and from x-axis I will say that my t sin theta should be equal to mr omega square. And how exactly I can say that? I can say this particular part from this particular word, it says stable, means all the forces which we have drawn on that mass m, they should be equal. So my t sin theta should be equal to mr omega square, my upward force t cos theta should be equal to downward force, which is mg. Now when I write this particular part, you have to be very careful, because let me tell you, when you're writing this r, radius, we have to talk about this radius over here. Okay, and this radius is something which you can definitely write in terms of L. How we can write that? Let me show you. This is the dotted line from point P, and this is your string. We are writing this as R, and this is given to you as L, and there is some theta. What you can do, you can resolve your L. You can resolve your L and you will get the adjacent component. If you take the component of L on y-axis, it is going to be L cos theta, and over here the value of L, if you resolve, it will be L sine theta. So basically I can write my value of radius in terms of L. That is one thing which you need to understand. When I am saying L, it is, if we have taken capital, it's the same L, okay, it is not some value which is different, okay. So I have to be very careful when I am writing this equation. I can do what? I can write the value of R as L sine theta omega square, correct? So basically the sign is present on both the sides. What you can write? You can write ml omega square is your tension, correct? Now let's say we have simplified our first equation from x-axis. Now I'm going to do the y-axis, which says T cos theta should be equal to mg. That means the tension value can be plugged as, from the first equation, you can plug the value of T, which is ml omega square. This is cos theta and this is mg. Cancel your mass. Omega square will be g. You can take the value of L cos theta to the other side. Your omega value can be written as square root of g L cos theta. Guys, if we know the value of L and the theta, if it is given in the question, we can also get an answer in terms of a number. So what we need to understand here, that we have approached this particular question with the given requirement, and then we are able to solve this with respect to the free body diagram which we have drawn over here. So I hope you people understood that what exactly is the importance of free body diagram when it comes to mechanics, because every single question, let it be from a different chapter, the requirement will be same, that you have to understand the diagram of FBD and accordingly you can solve. Now once we get this answer, let's move to the next part, which is our next question. So what we have to understand from this question is this. Now look here, the diagram is given to you. There is a uniform chain of length L is kept on a table such that a length of L by 3 hangs. Now you can do one thing. Whenever some information is given to you, you can write few things, that okay, length is given to me is L by 3. Definitely if this part is L by 3, I can simply say if total length is L, the length which is going to be above the table is 2L by 3, because 2L by 3 plus L by 3 you will get L only. The total mass of the chain is capital M. Find the work done by an external force in pulling the chain completely. Okay. Concept, definitely it is from work done. We need to understand when the chapter is work done, the formula which we know is force into displacement, which is the first formula flash in our mind, but there are a lot of multiple formula which you can have for work done, like kinetic energy, potential energy, change in kinetic energy, power into time. All these are the work done formula. Here in this case, I think if you pull the chain completely up, there is change in potential energy going to be happen. So we will approach this particular question with this particular formula, that what will be the change in potential energy for this chain, because that is the exact same amount of work which one need to do. Okay, understood. Now what do you need to understand over here? According to the question, we have to calculate work done, but you people need to understand one thing, that total mass of this chain has been given to M. So if I say L length, I will write it completely so that you will understand. Mass of L length is considered to be capital M. Then I can say mass of unit length. For unit length, you can do what? Take your L to the other side. It can be written as M by L. Means if you take unit length, the mass should be M by L. Now if I have a specific distance, mass of X length, for that you can do what? Your unit length mass multiplied by that X, it will give you mass of that X length. Now let me tell you, when I am writing multiplying with X, it is actually the same quantity. So length is something which is meter, x is also in meter. So definitely you have the only unit which remain in this particular part is also kg. What we can do when I'm calculating this particular question, when I'm solving this particular question, my work done is nothing, it is change in potential energy. I know that you people have learned this formula of potential energy, okay, and you simply say that my change in potential energy in this case will be mgh. But my point here which I'm trying to explain you that you need to understand that what will be the correct value of m and h you will take, okay. So there is not only a concept of work done there is not only a concept of work done apply over here, there is also one more concept which we say the concept of center of mass. If we talk about m, which m we are talking about? The suspended mass. So this suspended mass, because definitely you have to pull this suspended mass which is having its length given as x. If we have to calculate this suspended mass, it should be capital M multiplied by the length which is L by 3. I am using this formula, mass per unit length multiplied by x. So you will get your suspended mass is, wait a minute, mass per unit length and L by 3 is the same L we are talking about, you can cancel this. So the mass of suspended chain is m by 3. Whatever the total mass of the chain, it should be divided by 3, that is the suspended mass. Okay. The value of g, definitely it is some constant which is not going to be changed anyway. Now what about this h? People usually make a mistake for this h, because let me tell you, it is not only a concept of work done, but it is also a concept of center of mass. Because whenever you have elongated body, you don't have to consider the elongated mass, because the entire mass is supposed to be concentrated where the center of mass of the string will be present. For this suspended mass or chain, I can say that center of mass is present at half of L by 3, and when you do half of L by 3 you will get L by 6. Means my aim is to pull the chain only till the center of mass comes onto the table. So if I have to plug the value of h, be very careful, it should be L by 6. So when you solve this particular question, that plugging the value of mass which is m by 3, value of g as it is, and the height is L by 6, my answer is going to be mgl by 18. So basically the amount of work done which you need to do to pull this chain completely, it will be mgl by 18, which will be your correct option for this question. Yeah, so look here, a basic situation, but there are a lot of concepts which are involved, so you have to figure out one by one that how to get the correct answer. I hope everyone is clear till here. Now let's move on to the next question and we'll see that how to do that particular question. Okay. Moving on to the next question, it says a body of mass m is released inside a hemispherical shaped container on its smooth surface as shown in figure. So diagram is there, so we don't have to worry about the diagram. Calculate the normal force at point A and B, and there are options given to you. Now let's practice some question with the option, because see, my point here is, even if we figure out the 4 points which I told you, if you don't solve according to the option given to us, still there is no point in solving that particular question. So we have to solve in such a way that we should be able to get to the desired result which examiner want. Now the question is about the normal force. I know that it is chapter Newton laws of motion, and definitely if I have to approach this question, I have to take help of free body diagram. I am going to assume when this body which is having mass m is going to be slide down, it's going to have some velocity at this particular point, because it's a smooth surface, so there's no friction which we need to consider. So there will be some velocity which is going to be possessed by the body even at point B and even at point A. Okay. When I draw the free body diagram, look here how exactly we need to approach. We have to calculate the normal force at point A. I can blindly draw that weight mg is going to go down. My normal, which is always perpendicular to the surface, it is going to be here n, and I hope you people know that even it is something which is in contact with the surface of this hemisphere is actually something which is in circular shape, and circular shape is possible only when you have a centripetal force. So even on this body, you people have some centrifugal force which is written as mv square by r. The hemisphere radius has been given, so I am going to plug the same value. Now I don't think is there any other component of force which I am supposed to draw on this particular body which is at point A. So when I write the equation, okay, with respect to or at point A, when I write my equation according to Newton's second law, I can write that my normal is equal to mg plus velocity, to be very specified, at point A by r. Okay, I have figured out the concept, I have figured out the formula, I have written the equation according to the free body diagram, but I can't see any option which I have in the option, so I have to solve it further. So let me see if there is anything else which I can do. Okay, the word smooth, okay, that means I can consider one more thing, law of conservation of energy. The body is having some potential energy at the top, and if it is smooth surface, the entire potential energy is going to convert into kinetic energy. That means I can write that my potential energy, which is mgh, should be equal to my kinetic energy, which is half mv square. Now we have to be very precise with this particular part. Why? Because we need to calculate this velocity. When I am talking about velocity, it is the specific velocity which I have at point A. What I can do, from this point, if you see the drop in height, it's nothing but it is the radius of the sphere only. So what I can do, I can modify this equation, and I can say that my mass is m, gravity as it is, the h, the potential energy, the h can be replaced by r, because that is what the drop in height is going to come when the mass reaches from the top to the point A, and then here you have mva square by 2. Now look here, I need to get this mv square by 2, mv square by r. So modify it. So I take my 2 to the other side, and 2 to the other side, which will be look like 2 mg mva square, and you take your value of r down. This value which you are getting from second equation, guys, you can plug it in the first equation. So basically mva square by capital R can be plugged as 2 mg. So when I plug the second equation in my 1, I can get my equation as mg plus 2 mg. So my normal will look like 3 mg. Amazing. I got my normal reaction force at point A, but when I look at the option, if I have only one option available to me, I would have said, okay, we don't have to do for B point, but as there are two options, A and C, which is having the first value as 3 mg. Okay. Now that means we have to again use the same concept for body at point B as well. Okay, now let's do it. First thing what we will do, we will draw the free body diagram. So for free body diagram, let me show you at point B which are the factors which are going to play a crucial role. R normal, write it as N1 because you have already taken N. Your weight of the body, but don't make the mistake of taking it directly opposite to N1. Weight is something which is always towards the ground. So your mg is going to be experienced vertically downward in this way. That means we will draw a reference line, because we can say one thing, that this mg is making some angle, and here the angle which is given to you is 53 degree. So for your reference, if I draw a parallel line to the ground, you have 53 degree over here. So if this angle is 90 and this is 53, I can say that this angle is going to be 37 degree. Okay. That means I got my angle of weight with the dotted line which I have drawn. So that means if I have to resolve my weight, I will get adjacent component, which is mg cos 37 degree, and my vertical component, which is definitely mg sin 37 degree. But I don't need in this particular case, because I'm interested in my normal. So normal is present on y-axis, if you say so, or normal is something which is present over here. So don't worry about the vertical component. Now look here. One more thing, as we know that as the velocity at point B is taken as Vb, you cannot ignore that at this point the pseudo force which is going to be experienced is mvb square by capital R. So when you draw the free body diagram, you have to be very clear that you should show all the component of forces which are going to be act on that body, otherwise you are going to get confused. Now look here, when I am writing the equation from here, my N1 is balanced by mg cos 37 degree plus mvb square by R. Situation is a bit complicated because there is an angle involved, but don't worry, you can do it the way we have done at point A. So we are dealing here this equation for at point B. Now look here, let me tell you a simple trick. If you draw a triangle, because 37, 53, these are the very common angles. So if you are saying this is 90 degree, the side opposite to it will be taken as 5, and if this is 3, the angle should be in front of it, should be the smallest angle, 37, and if you say this is 53 degree, the side opposite to it should be 4. So write opposite, exactly opposite to the angle, 90 degree in front of that, 5. In front of 37 degree, it should be 3. In front of 53 degree, 4. So with respect to the angle, okay, bigger the angle, bigger the length, so you can justify this particular diagram, which you should always keep handy for yourself whenever there is any question which involve the angle in terms of 37, 53. Why? Let me tell you. Cos 37, you can write the value of cos 37 from here. That cos is nothing, it is adjacent. So here it is 37. Adjacent to this side is what? 4. So your value for cos 37 should be 4 by 5. What we will do? N1 mg 4 by 5 and this mvb square by R. Definitely I hope you people understood that what we need to do over here. The way you people have taken help of kinetic energy and potential energy in the first part, which is at point A, I am going to take help of it again. So my potential energy and kinetic energy should be same. So I am writing my mgh should be equal to half m, my velocity at point B, and square. Now you have to be very careful, because when you are saying mass, it's okay. G, that is also okay. H, from the highest point, this point B is present over here. So I need to know that what will be this height, because if you look at this height, this is not exactly, you can write it as R. So what you can say, if this is R, the adjacent component is always R cos 53, the opposite component will be R sin 53 degree. That means the height which I need to plug it over here, mgr sine 53 degree should be equal to half mvb square. My aim is to get what? My aim is to get the value of mvb square by r. What I can see, sine 53, okay, my diagram, the triangle will again come handy. Sine 53, this is sine 53, opposite by adjacent, opposite by hypotenuse, so 4 by 5. So cos 37 and sine 53 values are exactly the same. Okay, so what we can do, we can write mg, and I'm taking my 2 also to the other side. Okay, sine 53 is 4 by 5, and this is mvb square by capital R. So there is a modification of equation which I have done over here. The r I have taken down, the half mv square 2 I have taken to the other side. So my aim is, I got the value of mvb square by r as 8 by 5 mg. So this 8 by 5 mg which I am going to get, I am going to definitely plug it over here. Because definitely when I am going to plug this value over here, I would be able to calculate my N1. That is what the aim of this question is. So what I am going to do, this N1 is 4 by 5 mg plus it is 8 by 5 mg. Guys, I don't think we need to solve this particular part because you already know the denominator is common. So 4 plus 8 will give you 12, and 12 by 5 mg should be the correct answer. So ignore option C, your option A is absolutely correct. Yeah? There are a lot of concepts which comes in this particular question. There are a lot of things which we have actually brushed up in this particular question. So I hope you people would be able to relate with all this thing. What we need to understand that how quickly we can recall all the concepts which we have learned till now. Okay, because definitely 20 days if somebody is thinking that you can start from the scratch and you can get 130 plus score, no. Whatever you have practiced till now, we should be able to recall it, and you should be at the pinnacle of your performance. Whatever you have done till now, you should be able to recall it in exactly correct way, and you should be able to do all this thing in a very short span of time. Okay, I'm taking a time over here to explain things in detail so that you should be able to recall those concepts. Yeah, but definitely if you have practiced enough number of questions, there will be no problem in relating whatever you have learned till now. Okay, now let's move on to the next question. Okay, here the question which we have is, a body is executing SHM which is simple harmonic motion. When the displacement from the mean position is 4 centimeter and 5 centimeter, the value of the corresponding velocity of the body are 10 centimeter per second, 8 centimeter per second, then the time period of the body is. Okay. Concept, simple harmonic motion. Formula, there are a lot of formula, but I think we have given position and velocity. If you can relate with any formula in which you have position and velocity, I think it is velocity is equal to omega a square minus y square. Okay. So I have velocity and position, both the thing in this formula, so I will keep this formula here. So the moment I read the question, there are a lot of things which flashes to me. I am able to write down the thing which is required. Okay. Now let's try to solve this question, and according to the requirement, it is a question based on time period of the body. Means I need to calculate this omega because the thing which is given, it is given in terms of velocity and position, but they want is period. And I can relate with time period with only omega because omega is something which can be written as 2 pi f, and then I know that it can also be written as 2 pi by t. That is the reason in the option when you see all answers are actually written with pi. Now let's see how we can actually solve this particular question. Let's solve it. Now, if I see in such cases when the information is given very less, because as you read the question, whatever the information given to you, it's actually very basic and very less amount of information given to you, we usually go with the ratio part. Okay, we usually go for a division so that we should be able to cancel out the things which are common. So I'm going to use the same technique over here. So I'm writing when it is 4 centimeter the position, the velocity is 10. So let's write that velocity is 10. I'm using this formula. Velocity is 10 meter per second when the value of position is 4, which can be written as 16. Acceleration is something which is definitely going to be common, so we don't have to bother about it. The next equation which I can write for 8 centimeter per second, the speed and that time, acceleration will remain same, but you have 5 centimeter the position, square of it will be 25. Okay, I got my two equation. If I divide my equation 1 by 2, I would be able to simplify it further by saying that omega under root a square minus 16 omega under root a square minus 25. Okay, this can be written as 5 by 4, and definitely you can do one thing. You can get rid of this square. So if you get rid of this square, you will get omega is something which you can cancel over here. So if you take square on both sides, it will be 25 by 16. This is a square minus 16, a square minus 25. Okay, I think I would be able to calculate the value of acceleration from here. So I will say 25 a square minus 25 into 25 will be 625. 16 a square, 16 into 16 will be 256. 25 minus 16 will give me 9a square, and this is 625 minus 256. Okay, now let me give you the direct calculation, because there is no point in wasting time in calculation. So I would say when you solve this particular question, okay, 625 minus 256, we can write it as 369. This is 9a square, so a square will be 369 by 9. Okay, which you can say that your a square value will be 41. Okay, so we got the value of acceleration, and I have written a square because you need to know one thing. If we use this particular value of acceleration in my equation 1, what I am able to get, I would be able to get that this is 10 omega as it is, and this is a square, which is 41 minus 25. Wow, I can see that where it's going to be, because this is 16, so 41 minus 16 will give you 25, which you can say that your omega value is going to be 2. Correct? So when we get the value of omega, now I think we have to comment on time, and you can see that you can use this particular value over here. The time period can be written as 2 pi by omega. You can plug the value of omega, and omega value, the moment you plug, you get your time period as pi. So your correct option will be B. Okay, easy way to approach, but let me tell you, the list of formula, there are so many formula. We should be able to correctly predict whatever the information is given. First, you people need to identify that can I recollect any formula which consists of the same information which is given in the question. The moment you can relate with any formula, write it down over there. Then go for the requirement of the question. Like the requirement is time period. So we have related that the formula which I know, in that formula I have omega which I can relate it to time period. So that is the way you need to break the entire question, and you have to get the correct result. Okay, I hope people are clear with this particular concept as well. let's move on to the next part. Now the next question which we have over here, let me see the next question which we have over here. Okay, a body dropped from a height of 1 meter onto a floor rises a height of 25 centimeter after the first rebound, the coefficient of restitution. Okay, the diagram is not given, but I will draw a rough diagram for you people, because then I told you the information which is given in the question becomes more clear. So it is dropped. So most of the people know that when it is dropped, that means it is 0. Then it rebounds. I will write over here that it rebound. Definitely it will have some rebounding speed, because you can see that it was dropped from 1 meter, which can be written as 100 centimeter. It rebound to 25 centimeter. Okay. Coefficient of restitution, if I recollect the formula for coefficient of restitution can be written as the ratio of velocity of separation, which is v2 minus v1, velocity of approach, which is u1 minus u2. I don't think anybody is having a problem in recollecting the formula, but even if you recollect the formula, you need to figure out few things, because here I can see when you people use this particular formula, there are situations given to you where you can see the initial speed is related with u1 and u2 and final speed is related with v1 and v2, and you have two bodies involved over there. In this case, you can see the object which has been dropped, it can be treated as a one body. Okay, so you should not get confused that where exactly the second body present over here. Let me tell you guys, the second body which you can consider over here is the surface itself. Okay, so if I say initial, so for initial what you need to understand that you should be able to calculate your initial velocity for the body which I am writing it as u1 before it going to be collide with the surface, and I think we can calculate that. Just before the collision, there will be some maximum speed attained by this particular object which has traveled 100 meters down. We can calculate that. Your initial speed of the surface, if you wanted to figure out, it is definitely 0, because our surface is still, it's not in motion. Okay, so I can see that I can relate my u1 and u2 now. Then what about this v1 and v2? Okay, this v1 over here which I am writing, it is the speed of the ball after making a collision with the surface. But again, if you talk about the surface speed, it is going to be 0. So I should be very clear with this particular concept that my u2 and v2 value which I have written over here, it's going to be 0. No way. Because when I figure out the diagram, I think I have no problem now in solving this particular question. But now the question comes, we have given height. Is there any way we can relate the velocity with height? I think yes. What we can say that at this particular height, whatever the potential energy you have, it is going to be completely convert into kinetic energy at this particular point. So my potential energy should be equal to kinetic energy. My mgh is going to be equal to half mv square. So I think velocity can be written as square root of 2gh. This is what the formula which we require. Both the sides we can write our velocity in terms of h, because if you read the question, the information given to you is the height. Okay, the information which is given to us is the height, so we have to relate that information in our question. So what I will write that at this particular point, before it make contact or collision with the surface, my initial velocity or the final velocity which I will reach when it hit the surface is 2gh1, and I hope you people know that h1 will be what? Your h1 is nothing, it is actually the distance traveled by that object for that particular speed. So it is dropped from 100 centimeter up, so that is what it is going to attain, which is written as h1. For v1 if we write, okay, because after making a collision, the kinetic energy is going to convert into potential energy. This formula is again valid, but let me tell you, after making a contact, the rebounding speed is going to be changed, it's going to be less, and that you can relate with the height which is given to you 25. So I will write 2gh2. Correct? I have all my values. I just simply need to plug all this value and I will get my correct answer. So here, if I see the value of V2, 0, amazing, minus sign. Now V1 is 2GH2. Now there will be some people who can get confused that I have minus sign over here. That means my final answer should consist of minus sign. Let me tell you guys, the U1 velocity which you have taken, it is down. The V1 velocity which you have taken, it is up. So you can consider one of the velocity in such a way, if you're considering down is negative, okay, so this value of 2GH2 which you are plugging, it need to be plugged with the minus sign, which indicated direction. So you can basically, you can cancel because minus minus will become plus. Your U2 is 0, that means the only value which you have U1 at the bottom, which is 2GH1. Okay, now it's very easy to solve. You have E, let me tell you, the value of U2 is 0, which I am not writing here, but still I feel you should not get confused. So if I take a square root on both sides, you people can write 2GH2, 2GH1, 2G is common which will get cancelled. Your H2 is 25, your H1 is 100. I get this as 1 by 4. Taking a square root, you will get your E as 1 by 2. I think my correct answer is this. A simple concept, okay. The formula which we have used is coefficient of restitution, which is definitely one particular question which comes under the collision part, which you have learned in work energy power. So you should be able to recall all this thing. Let me tell you, the part which we need to crack according to the entrance examination is the one which I have pointed over here. You can't get confused with the value V2, V1, U1, U2. So you should be able to correctly approach the question, and for that definitely the diagram will help you and you can solve the question accordingly. Okay, let's move to the next question, which is question number 9, which says the displacement of a particle of mass 1 kg on a horizontal smooth surface is a function of time given by x 1 by 3 t cube. The work done by external agent for 1 second is, okay. Usually when you people actually prepare for NEET, you avoid doing questions on calculus, but let me tell you, this is a very basic calculus which is involved over here, which you can easily solve. Because when you talk about the concept, work done, I think everyone knows the formula for work done, which is force into displacement. But here one thing which you need to understand, the displacement which is given, it is not constant, okay. It is something which has been given a relation with time. That means if time value keep on changing, your displacement will also keep on changing. Mean this particular question will definitely we can solve with the help of calculus, because your distance or the value of x is variable. So what we need to do, we need to calculate something with the help of a very small quantity. So we will go for Tx, okay. So small work done which can be denoted by dw, and small displacement which can be denoted by dx. So this is what basically we have to do, and when we integrate both the side, the total work done will be F, and this is the formula which I can think of. Okay, when I read the question, I can see that I have given x, I have given time, the mass is also given to me. But when I see the formula, I have force and displacement. Is there any way I can calculate force? Because I think if I have to calculate force, the only thing which I can think of is Na. I have mass, so somehow I need to think, is it possible that I can calculate acceleration from this? Yes, possible. How? I'll write x equal to 1 by 3 t cube. If I differentiate my x dx by dt, it will be, I hope people know the differentiation of t cube, 3 will come in front and 3 minus 1, which will be t square. So differentiation, this is a very basic differentiation which I've done, and I hope you people know the value. So the dx by dt, change in position by change in time, you get velocity. Let me tell you, we got velocity. So velocity is something which we can write it as t square. If I differentiate it again with time, I am going to get 2, this is 2 minus 1, so it will be power 1 only, which we can write as 2t. Means dv by dt, dx by dt is velocity, dv by dt is my acceleration. Wow, I am getting my acceleration. So that means what I can say, that force value is mass into acceleration. Mass is 1, acceleration is 2t. That means force is something which can be written as 2t. Wow, I have figured out that the F value can be written as 2t. How we can write the dx value? Is there any way we can write the dx value? Yes, look at this particular part. Dx can be written as t square, and you can take dt to the other side. I think I have dealt with this particular formula, integration of f dx, and I have the value of f, I have the value of dx. What I am going to do, I am going to solve it. Work done. The value of f, it is 2t. The value of dx, t square dt. Interval is given to you, and you can say the time interval can be taken as 0 to 1 second. Okay, so always the interval value is important. If there is some different value of time is given, definitely the interval will change. Now what I can do, guys, it is 2 which is constant. Inside the integration sign you will see it is t cube dt, and if I have to integrate t cube dt, it will be t raised to 4 as you add 1 in the power, and the same power is written in the denominator, your lower interval and upper interval. Here in this case, the lower interval and upper interval value, even if you plug, so upper interval is 1, so 1 raised to 4 will be 1 only, and this is 4 minus lower interval which is 0. So you can see that work done which we are going to get it from here, it will be 2 by 4 which will be 1 by 2, and I think work done can be written as 0.5 joules, which will be the correct answer. Yeah, so this is one particular question which I have taken where you have to use the concept of calculus, and you need to understand that this is how we need to approach. Correct? So guys, you have to be very careful. The question which comes from calculus, where you have to use a calculus, there is a very basic calculus is involved, and you people are familiar with this type of question and you have practiced such type of question. So don't avoid such question, because these questions are something which are always very simple, basic. Okay, we have to use the fundamental formula from calculus and we can get the desired result, and this is something which we can do. Yeah, okay. Now let's move on to the next question. Okay, and this next question which we have, which is question number 10, which says find the value of tension and acceleration of the given system. So there is some system which should be given to us. Okay, wow. If you look at this diagram, the diagram looks a bit complicated, but the aim of this question is what? Tension and acceleration we need to calculate. I hope you people are aware that in this particular case, this part, which is a wall and your small pulley is fixed to it, if you remember the concept here is actually constrained motion, because one of the pulley has been fixed with a wall. Okay, so I hope if people remember the constrained motion concept, then the next thing is your formula. The only formula I can think of is my net force, which is F equal to ma, where we have to make an equation. How do we approach? Definitely free body diagram. There is no other choice which we have in this particular case. Now the requirement of this question is you have to comment on tension and acceleration. Okay. Now if I draw my free body diagram, let's say this is 60 Newton, because mass is given 6 kg, gravity is 10, 6 into 10 will be 60 Newton. The tension is from this point of contact. I always highlight the point of contact so that there should be no confusion with the tension, because if this is the point of contact with the pulley, the tension will be this, because that is how it appeared to be pulling. So I have defined my point of contact with 6 kg, and for that I have defined my T. As it is a continuous string, I think at this point of contact your tension is going to be here. At this point of contact your tension will be here. Because as we know that it is a massless string, and in the same string the value of tension should be same everywhere. If this is a system, I can see that there are two T's over here. That means if I have to show my tension value for 4 kg body, okay, first let me show you this point of contact with the pulley. Your tension should be equal to these two, so it can be written as 2T, okay, and the same value of 2T with 4 kg you can define in this way. In my free body diagram, I think I have drawn my component and I have shown all the forces. No, there is one thing which is missing, because we know that this 60 kg or 60 Newton is something which is going to take this body down. So I am writing here the acceleration is going to be A1. As you have connected 4 kg, let me tell you this string is roll over the small pulley. So the acceleration of this 4 kg body is not going to be same, because the two objects are not directly connected with the same string. So the acceleration value will be A2. Question is very simple, but the point here is you need to remember the concept of constrained motion, because what we need to understand, if I have only two unknowns, T and A, I can solve this question by making two equations, which I can easily make from 6 kg body and 4 kg body. But this particular diagram, you can see there are three unknowns. We have T, we have A1 and we have A2. That means the requirement, the number of equation which we require, it's 3. I'll make the first equation from the first diagram, which you can simply say 60, as the body is going down, whichever component is bigger, always write first. 60 minus T equal to 6A. If you're wondering, this is net force equal to MA. Your net force will be the subtraction of two forces, 60 minus T. Let me tell you, if anyone write this particular value as T minus 60, it will be wrong. Always write the component where the body is moving. The body is moving down. That means 60 is bigger. So 60 minus T equal to 6A, and make sure that it is A1, so that you should not get confused. Okay. The second equation which I can make it from here, 4 kg body, where I can say this is 2T equal to 4A, because that is the only force which I can see. So if this is my first equation, my second equation is 2T equal to mass into acceleration, which is 4A2. Okay. I think I have made my two equation, and now I need to do with the third equation. Now usually people, what they do, for third equation they actually go for this particular part, where you can see if I isolate this section from here, this is how it will look like. I can see there is some acceleration A1 involved over here, and there is some acceleration involved over here, A2. But if you see something, the string, this entire string, there are two pieces of string on either side, and here this string is only having one particular acceleration. Usually people try to relate it from here, and they actually do a mistake by the relation which they have to derive between A1 and A2. So I will give you a simple concept over here, that whenever you have this situation, don't make your third equation from this particular diagram. You can make your third equation by simply using this concept, that in any system, your summation of tension and acceleration should be 0. When I take the summation sign, what does it mean? Summation sign means that you have to consider the mathematical operation plus and minus sign. Now let me tell you what I am trying to explain you. If you look at this system, let's make an equation for T and A. T is up, A1 is down. So that means when I am going to multiply T and A1, the two things, tension and acceleration, they are in the opposite direction. Choose a negative sign, because I have written summation. That means you will go according to the sign of T and A1. So when T and A1 are opposite, write with a minus sign. When T and A2 are in the same direction, write with a positive sign. Because this you have made from here. Now if you make one equation from this body, 2T and A2, product of tension multiplied by acceleration. The way we have written, very important. Let me make a cloud over here. Let me put a star. Sign, obviously plus sign. Reason, your tension and acceleration A2 both are in the same direction. That's the reason we have taken a plus sign. When do you take a minus sign? When tension and acceleration are in the opposite direction. Now what we can do over here, we can say this summation should be 0. Now what I can do, take your value of TA1 to the other side, you can write it with a plus sign, cancel your T, you guys got a relation between A2 and A1. Now what we can do, the moment you get your third equation, I think our job is done. Now we just need to plug the value to get the desired answer. So what I'm going to do, I'm going to plug the value of A2 in my second equation. So when you plug the value of A2 in second equation, it will be written as 2T4. A2 can be written from the third equation as A1 by 2. So when you write this as A1 by 2, you will get 2T equal to 2A1. This is my fourth equation. Now if you solve fourth and one equation, 1 and 4th, how we can solve? Divide 1 by 4th, you will get 60 minus T divide by 2T, 6A1 divided by 2A1. Your A1 get cancelled. Guys, we can solve this and we can say that 60 minus T equal to 60. So you will get 5T equal to 60. I think the tension value can be written in this particular case as 12 Newton. We got the value of T, and I think if we got the value of T, it's very easy that in fourth equation you can say 2 into 12, this is 2 into A1, so you people can say it will be 12 meter per second square is the acceleration, A1. Guys, let me tell you, when I'm writing A1 as 12 meter per second square, what do you need to understand? The body A1 is having more acceleration, means it is going to go down with much faster pace compared to your A2, because your A2 value, if you relate from this particular equation, your A2 value is going to be A1 by 2, which is going to be 6 meter per second. So you can see the two body are not moving with the same pace. 6 kg body is moving down with a faster pace compared to the 4 kg body. So there are somewhere around 10 questions which I have discussed in this particular class with you. I hope that you people are able to recall all the concept, okay, which we have learned in mechanics. The topic which I have showed you in the beginning are very important, and let me tell you that you can expect at least 35 to 40 questions from this particular topic which I have showed you. Yeah, the pattern has been changed. So 55% to 75% question if you are getting from the first 5 units which I have shown you in the beginning, you would be able to easily score more than 130 plus. There are a lot of topics which I have not written in the first slide, because definitely if anyone who is planning to go beyond 160 plus, you can brush up those topics as well. Yeah, but during the 20-day session, these are the things which we are going to revise, and we are going to recall all the concepts which we have learned a few months back. Okay, so with this particular question, I will say bye-bye to all of you, and definitely wishing you all the best for your exam. So thank you guys, bye-bye and take care.